This is lesson 7.6, solving inequalities. An inequality is a mathematical sentence formed by placing an inequality symbol between two expressions. That would be your definition for inequality. I want to show you the four inequalities that we're going to be using in this lesson. They are, they are less than or equal to, greater than or equal to. Now less than, when you want to graph that, less than would be an open circle at whatever number it is, and arrow going to the left. Less than or equal to would be a closed circle at whatever number we're talking about, and an arrow going to the left. Greater than would be an open circle at the number, an arrow going to the right, and greater than or equal to is a closed circle, and an arrow going to the right, which I'll explain a little more later. Just make sure you understand which way open or closed circle and which way the arrow is going on these four inequalities. So let's do an example. First example is d minus 2 is less than or equal to 1. Okay, first we're going to solve this like we do our regular one-step equations. So we're subtracting 2 from both sides. That means you want to do the opposite, so you want to add 2 to both sides. So that goes to 0, and you have d is less than or equal to 1 plus 2 is 3. So if we want, it says now graph the solution. So draw your number line. So let's say 0 is here, it has to be 2, 4, and negative 2 here. All right. So we've got our circle is going to be at 3. Now it's less than or equal to, so you know that's going to be a closed circle at 3. Closed circle, and it's less than, so that means your arrow is going to your right. So your answer would be anything 3 or less would solve the equation, or solve this inequality. Okay. A couple more examples. You have 6 is less than t minus 5. So you would add 5 to both sides. That goes to 0, and you got t on this side. 6. To me, it's helpful if you go ahead and keep the variable on the left, so let's switch this around to t is greater than 6. Graph that. So let's say that that's 8, 6, 4, 2. Okay. So we have an open circle at 6, and it's greater than, t is greater than that, so your answer is going to, arrow is going to go to the right. So your answer is anything greater than 6 would solve this inequality. All right, here you're going to subtract 9 from both sides. Go to 0, you got w is less than. Signs are going to end up being the same, so you add and keep the same sign. So w is less than negative 13. So on number line, let's see, that's negative 14, negative 12, negative 10, negative 8. So less, open circle, less than at negative 13, and it's less than that, so your arrow will be going to the left. Again, so your answer would be anything less than negative 13 would solve this inequality. Alright, now let's go to multiplication and division type inequalities. This is the only problem you're going to run into with working these, the exception to the rule, more or less. You have to reverse the inequality when you multiply or divide each side by a negative number. For instance, you got a negative 4w is less than 20. So to solve this, you would have to divide both sides by a negative 4. Again, when you multiply or divide by a negative, then you have to switch the sign of the inequality. So again, that goes to 1w, and instead of less than, now it's going to be greater than. 20 divided by 4 is a negative 5. Greater than a negative 5. Then it says graph the solution. Okay, so let's 5. So let's say negative 6, negative 4, negative 2. So negative 5 would be here. It's an open circle, and it's going to be w is greater than that. So arrow going to your right. Again, when you multiply or divide by a negative number when you're solving these inequalities, you have to switch the inequality sign. Here's another example. You're multiplying by 1/5 k is less than or equal to 12. Now the rule is, if you remember right, you cannot divide by a fraction. You have to multiply by the reciprocal. So that's how we're going to solve this one. So the reciprocal of 1/5 is 5. So we're going to multiply both sides by 5. That's positive 5, so the inequality stays the same. You put that over 1 if you want to, so that divides out, leaving 1k or just k is less than or equal to 12 times 5 is 60. Graphing that. Again, it doesn't matter where your graph starts as long as you have increments involved. So let's say that this is 62, 60, 58, 56, 54. So less than or equal to, so that's going to be a closed circle at 60 with an arrow going as less than, so they're going to the left. All right. Now we have division. So x divided by 3 is less than -4. So instead of dividing by 3, you got to do the opposite. So you're going to multiply both sides by 3. But again, you're multiplying by a positive 3, so your inequality will stay the same. So that divides out, leaving x is less than -12. So graphing that again. So you've got -14, -12, -10, -8. So less than is going to be an open circle at -12, and it's less than, so going to your left. So that's, again, your answer would be anything less than -12 would solve that inequality. And finally, we want to write two equivalent inequalities represented by the graph. Okay, now we're going from a graph to an inequality. So let's say we're going to let a variable be x. You got an arrow going left, so you know it's less than. It is a closed circle, so that means it can include 5, so it could be less than or equal to 5. So that's one inequality. Now they want you to come up with another one. So another inequality could be, let's go x plus 1 is less than or equal to 6. That could be another one, because when you solve this one here, you subtract 1 from both sides, and you end up with x is less than or equal to 5, which is the same as this one here. So these two inequalities both represent this graph. So this concludes our lesson on solving inequalities.